Before electric motors and industrial machinery became standard, many rural workshops relied entirely on natural forces. Across Europe, water power shaped everyday work, driving mills that processed grain, timber, and raw materials. This film shows how a traditional water-powered sawmill operated, capturing a way of working that survived well into the mid-20th century. What you are about to see is real archival footage of skilled manual labor guided by water, wood, and experience. The sawmill was run by Josef Schneider, who learned the craft not through formal training, but by working alongside his father. At the time, sawmilling was a profession passed down through observation and daily practice, rather than official apprenticeships. After the war, Schneider took over the mill himself and continued operating it with only 1 or 2 helpers until the mid-1960s. As demand declined, he was often able to manage the work alone. Water-powered sawmills like this one have existed since the late Middle Ages. Historical records show that this mill was already functioning as a cutting mill in the early 19th century, reflecting a long tradition of water-driven wood processing. The operation of the mill begins with controlling the flow of water. By opening or closing a gate in the weir, the sawyer determines how much water enters the channel. This channel guides the water beneath the working platform toward the wheel. The water wheel itself is an overshot design, meaning water enters from above, using gravity to maximize force. Weighing several tons, the wheel turns slowly but steadily. Large wheels of this type are limited to about 10 revolutions per minute, setting the rhythm for the entire sawing process. Each rotation of the wheel translates into multiple cutting strokes. Under good conditions, the saw moves up and down nearly 200 times per minute. While most overshot water wheels reach around 80% efficiency, this mill achieved significantly more due to careful construction and well-maintained bearings. Power from the wheel is transferred through a system of shafts and gears inside the mill. These components guide the motion step by step, ensuring that the energy of the water is used as effectively as possible. Belts and pulleys carry the motion further into the mechanism. One belt drives the saw frame itself, while another controls the return movement of the log carriage. The balance of these wooden pulleys is critical, as poor alignment would result in energy loss and uneven cutting. By operating a lever on the working platform, the sawyer engages or disengages the cutting process. This simple action shifts the belt onto a fixed drive pulley, bringing the entire system to life. Rotating wheels are connected to long wooden rods that convert circular motion into vertical movement. This transformation causes the saw gate to rise and fall in a steady rhythm. Only once the feed mechanism is engaged does the actual cutting begin. With each downward stroke of the saw, the log carriage advances slightly. This synchronized movement allows for controlled, precise cuts, driven entirely by water power and mechanical timing. In many rural parts of Germany, water remained the primary source of mechanical energy well into the 20th century. Unlike large industrial centers, Steam-powered sawmills were slow to appear in these regions. As a result, traditional water-driven mills continued operating long after industrialization had reshaped production elsewhere. This sawmill stands as an example of how older technologies remained practical, reliable, and deeply rooted in local life.